Hi, in this video I want to talk about the answers to this particular set of geological problems. Remember, you're a geological consultant looking at this proposed route for a new motorway. There's a whole series of engineering geology problems and challenges here, which as geologists we need to first of all identify, and secondly then to try and suggest possible solutions for this. Let's start in the south and work north. This is our first potential problem. Here we've got a rock slide above the road on a steep slope. Clearly this poses a risk uh, to the road. If these materials slide, it could either damage the road or even take the road uh, away with it. Clearly this motorway can't operate safely if this slide isn't fully understood and also held in place. If you look at the cross sections, you'll see that the rocks in this area are dipping limestones. So it could well be possible to bolt these rocks in place. So you drill through the loose layers on the top into some sounder bedrock beneath and fix those loose blocks of rock at the surface using a long bolt cemented into the rocks below to hold them still. Other ways of dealing with this could include building a retaining wall at the bottom of the slide, uh, either out of gabions, like by A block, or by, if you want more security, building a reinforced concrete wall. By supporting the bottom of these slides, you hold the rest of the rocks behind it in place. Whichever way you do it, though, it will be an expensive solution. The next potential problem we can see here. Here we've got a scree slope above the road. So again, we have a problem of rock material perhaps falling onto the road. But in a lot of ways, this scree slope is more difficult to deal with. Scree slope, as we know, is weathered, broken fragments of rock. In this case, it'd be limestone. Now, these loose materials can't be pinned in place. There would need to be another solution put in place. But it's also quite a large area. So a solution like putting netting across the whole area and bolting that netting into solid bedrock beneath would be quite a large scale and therefore expensive solution. Perhaps a better way of dealing with this particular hazard would be to build a series of mesh fences across the scree slope to accept the fact that these rocks are going to move downslope, but to have something in place to catch them. There are places, for example, on the rail network in Scotland, that have a clever system of wires where if a rolling boulder breaks the wire, a signal will be triggered to make trains stop. Maybe something like that on this road could increase the safety. But this one is a difficult problem to deal with. The next potential problem is here. Now this is some distance from the road, but what we have here is a river disappearing into the rock. It's a feature we call a swallow hole, and they're not uncommon in limestone areas. Now, as a geologist, where I see a swallow hole like this somewhere near a major development, I want to know more. I want to know where that water is going. It may disappear into a cave system deep beneath the road um, and not particularly be a problem. This may, though, be a shallow cave system that runs underneath my road, um, creating a cavity that can collapse, creating a sinkhole hazard. Now, that would obviously be a disaster for the motorway. The thing is, at the moment, from this information, I don't know. What I need to do is I need to trace that water. Where does it end up? Where does it flow to? Would I try and find underneath the route of my road if there are any caverns and void spaces in this limestone? It's a potential hazard that only more geological investigation can solve. If any are found, it may be that that area needs to be bridged. It may be that those caverns need to be filled, although we still need to think about how water would actually travel through them. We'd also have to think about seasonal differences. Could it potentially be more of a problem in the winter with greater flow of water than it would be, say, in the summer? The next potential hazard is here. We've got another slide. This, though, is above the reservoir. The reservoir held back in that valley behind the dam, if that fills with water and we have a rock slide into it, we could end up with a situation similar to you jumping into a full bath, where that rock material flowing into the water displaces the water and pushes it over the top of the dam in an uncontrolled way. Again, if that reservoir is to be filled, that rock would need to be stabilised, either by digging it out or by pinning it in place. We've also got the location of this dam. Again, if we look at the cross section, we can see that this is an area of limestone. Now, limestone is quite a strong rock. It could well support the weight of the dam, but a far bigger issue is its permeability. Water can flow very easily through the cracks and through the bedding planes of limestone. If in this case, where that dip of the limestone is going away from the dam, we could end up with significant amounts of leakage, maybe even undermining the dam itself. Certainly there'd be a problem of loss of water. Resolving that would involve grouting the rock, drilling into those cracks and cavities and pumping in a wet cement slurry that fills up the void space, acting like the cement in the rock, in a sedimentary rock. In an area like this, that could well be a very expensive solution. North of the dam, we see another slide that could cause an overflow. Let's keep on looking. There's another hazard here. This stream, called Black Brook, is flowing in really quite a straight line. Now, straight lines in geology are rare. This river is clearly following some kind of weakness in the rock, possibly a fault. Now, faults can be pathways for water. This stream is flowing above the road here as the road passes through a tunnel. That tunnel may find a zone of broken up rock along a fault. It may be allowing water to get into the tunnel. Whichever way it's going, as a geologist, I want to know why that river's running in a straight line. Is it potentially going to cause problems for the tunnel? If it does, I need to line that tunnel. Ideally with a concrete ring, like the channel tunnel, or maybe even just to spray some shotcrete if it's just some loose broken rock that we need to try and reinforce. The next potential hazard is here. This ridge has clearly got a different rock type from the surrounding rocks. It's a long, straight structure. It's a long, straight structure. And if we look at the cross section from A to B, we can see that we've got a dike. There's an igneous rock there. That's going to be harder to excavate than the surrounding sandstones. As a tunneling geologist, you'd need to know that. You'd need to predict where that would be to ensure that your tools are ready to cope with that task. The cross sections here show some of these issues. In the south, in the north, there we have our tunnel, and it's actually right on the crest of an antiform. That could mean there's extra cracking in that tunnel. As the rocks get bent, they can break. We also see the presence of the dike there. The dam in the middle here, between C and D, as we've already said, on limestone that's dipping downstream, that could well lead to a lot of water loss underneath that dam, and possibly even undermining the dam. Finally, we've got our rock cutting here in the south, and we can see clearly the problem here with the dipping limestone. That would need to be secured to make sure that no rock was going to slip onto that road. So we can see, with all of these issues, we need to look for the potential issues from the geology, both at the surface and underground, and to think carefully about how we could actually resolve each of these problems. It's the way a lot of geologists earn an interesting and good living. Anyway, if you have any questions about it, please ask me the next time you see me. I'll see you then.